Here we're going to look at another perimeter and area type problem. So in this case, we have two parallelograms sticking together. So we have parallelogram ABEF and BCDE as shown. It's also given that CD is 24, DE is equal to EF, which is equal to 18, and AC is 30. And by the way, the unit length is centimeters right here. So we need to find the perimeter and area of this whole figure as well as the perpendicular distance from F to AB, which is this length right here. First, let's start off by proving that these two parallelograms are actually congruent. So, first notice that this side length is obviously equal to this side length, which is also equal to this side length, which is also equal to this side length. And next, notice that this side length is equal to this side length, which is also equal to this side length. So we have covered all corresponding side lengths which are equal to each other. And so these two parallelograms are actually congruent. And let's start off with the perimeter. Notice that we have four side lengths with length 18 marked in red right there. So we have 4 times 18. Plus, we have two side lengths with side length 24. So let me just indicate that right there. And don't forget the unit length, which is centimeters in this case. You'll leave with an answer of 120 centimeters. Now for the area, we need to do a little bit more work, but it will still be simple. So let's just project this line EB to line AC, and let that point of intersection be P. And notice that this is perpendicular, or this forms a right angle. However, since notice that triangle ABC is isosceles, we know that this length is equal to this length, and therefore this length right here, AP, let me just indicate that right there. So if AP is equal to PC, which is equal to 15 centimeters. And this will be helpful because notice that 15 right here is actually the height of the parallelogram BCDE with corresponding sides to our base DC. And furthermore, we know that these two parallelograms are congruent, so we can just calculate the area of one parallelogram and then multiply it by 2. So hence, the area will be 2 times 24, which is our base, times 15, and then centimeters squared for the unit, leaving us with an answer of 720 centimeters squared. Now another way to calculate the area of this figure is that you can try to cut off this little triangle on the top DEF and then move it into this space right here for triangle ABC. And you can do that since these two triangles are actually congruent, which I'll leave you to prove it by yourself. And when you do that, you leave with a rectangle with side length 24 and 30. Notice that this diagram is not to scale, and therefore its area will be the same, which is 720 centimeters squared. And finally, for part B, let's just suppose our perpendicular distance right here be A. And notice that we can relate an equation in terms of A relating to the area of the parallelogram ABEF. So let me just write that right here. We can calculate the area of ABEF in two ways. By taking AF as our base and AP as our height. So that will be 24 times 15. But it also can be obtained another way by taking the side of EF as our base and of course our perpendicular distance A as our height. So that will be 18 times A. Solving this, you'll get that A is equal to 20 centimeters, which ends this video.